But
so
now,
5.3 part 2. So all we're doing is building off yesterday's stuff. So from 19 to 22, I'm just going to do 19, and that'll give you sort of a pattern to follow doing yesterday's stuff in a different setting. 23 to 26, looks like I'm doing number 20. Or no, looks like I'm doing 23. I wrote the wrong number here. That's not a 25, that's 23. So I'll do 23, and that can take you through that zone. 27 to 30, I'll do 27, and then we should be okay. There's not really any more background information to this than what we already did yesterday. So 19 I'm doing, and 19 is like a harder than average question of this, so it's kind of handy that I'm doing 19 for you. What we learned about yesterday was if we had a graph and it had sort of like a beginning and an end, we were going to be able to find the area that was between that curve and the x-axis. If that shape was above the x-axis, it was a little different kind of number than if we were below the x-axis. How would that have been different, above versus below?
Positive versus negative.
Positive versus negative. 19, they haven't shaded this in exactly the way you'd prefer for 19 to be shaded in, because what we were designed to do yesterday is go from curve to x-axis and have that be the area that we're trying to find. Number 20 is going to do that naturally. 21 is going to do that naturally. 22 is going to do that naturally, but 19 doesn't do that naturally. 19, they shaded the blue on the wrong side, and that's just kind of mean. Another thing they did on 19 that's fixable for us, they have a graph that's sort of like this. I would think you'd quickly agree with me. You'd rather have the graph just be there. Just life would look simpler if the graph were there. This was the equation y equals x squared minus 1. What part of that equation forced us underground?
-1.
The minus 1. If we'd instead graph y equals x squared, that wouldn't change really anything about how much space we have there. It would just, instead of sending us from -1 up to 3, it would send us from 0 up to 4 if we just sort of like pushed it up a square. It would still end at 2. That's going to be a simpler way for us to attack this problem on 19. It's just kind of like, let's drop the -1, which essentially nudges the graph up a square. It'll just make our life be a little bit simpler. For 20, if you wanted to make 20 touch the origin, you don't want to lift it up, you'd want to like push it down the 3 squares. How could you change 20's equation if you pushed it down 3 squares?
could you get rid of the positive?
Get rid of the positive 3, and that'll make your life simpler on that one. Okay, but 19, what we're looking to do is what we did yesterday, is do the integral from 0 to 2, because we always use the x-axis as our numbering scheme for what's called the limits of integration. We're going to do the integral from 0 to 2 of x squared. And in theory, I'll always try to remember to just write that decorative dx, even though the dx doesn't really do anything. It's just always there. How can you do that problem?
With the x squared rule?
With the x squared rule. How's that one go?
X cubed or b cubed over 3.
So we're going stuff over 3.
Minus the a squared.
Over 3. Okay, what'll go here?
4?
Not 4,
0.
not 0.
8.
8. We go cubes over 3. The squared rule was creating cubes over 3. So 2 cubed over 3 is that, and then this is 0, which that's just 0. So this would total 8/3. The answer is not 8/3. It's close. Some of the other problems we'd be done. But for this question, where that would live is here. This is where 8/3 lives. 8/3, when we use this formula, the integral sign, it's always going to find the area from the curve to the x-axis. So it's 8/3 under the curve. We need to know the number that's above the curve because they made this like unnecessarily harder than we wished it would have been. How could you like reason that out?
Do the area of the rectangle minus that.
That's correct. We'd have to figure out the area of the rectangle that we just created by accident. How much is the area of the rectangle? 8 minus the 8/3 that's in the space that we don't care about, but that we can find. What will that be?
16.
16/3 would be fine. 5 1/3 also fine. Question about 19? Okay, for 20 will be a lot like 19. You could drop the +3 and change the picture. We already talked about that. To do 21, you're going to have to do it in two pieces. You're going to have to do one integral from 0 to 3, which is going to turn out positive because it's above. Then you'd have to do a different integral from 3 to 4, which is going to turn out negative because you're below. And then here's a detail that might be worth jotting down in a note somewhere. When they use the word area, areas cannot be negatives. So when you go to do 21, because they're asking for the area, you'd have to turn the negative portion you'll find into a positive number and add it with the other number that was naturally positive. When they use this symbol, negatives are allowed to happen. If they use the word Riemann sums from yesterday, negatives are allowed to happen. But when they use the word integral, negatives are allowed to happen. But if they use the word area, areas are specifically only positive, so you might have to turn some negatives into positives when they ask you about the area. Something to 22. 23 is going to be a good prep for 21, 22 because it's going to come out in two portions. So we'll do 23. 23, they say A, graph this, and we shall. They say B, integrate it, which will mean to do a thing like this, which we shall. And then they say also C, find the area, which is the conversation I just had about you'll have to make everything positive and put the pieces together. So if it's x squared minus 6x plus 8 that we're after, how, since your Algebra 1 days, would you pretty much always approach any problem that you were given x squared minus 6x plus 8?
Probably right, like factor.
Factor it. This would go xx
Minus
minus minus
4, 2.
4, 2. Then this would tell you a number,
Positive 4.
+4. This would tell you a number, +2. How those numbers are going to manifest themselves on the graph, those are going to be the points where we touch the x-axis. So we're going to touch at 2, we're going to touch at 4, and that's like the beginning part of our graph. Anything with an x squared is what shape? U's. Sometimes U's go right side up. Sometimes U's go upside down. There's a couple ways you can figure out whether this particular U is right side up or upside down. Anybody have an idea of how you know if that's right side up or upside down?
If the x squared's negative or positive?
Okay, if the x squared's negative, then it's
Upside down.
upside down. And if the x squared's positive,
Right side.
it's right side up. So this particular one
Right side.
is right side up. That's fine. Another way you could decide whether it's right side, upside down, or right side up. We could come up with another point. What's a nice easy number to always plug in?
0.
0. 0 into this gives you out 8. So if you wanted to, you could figure out that 8 high is a touch point there. That's fun. Another thing you could do is grab your calculator, graph it, see what it does. It'll be right side up. But for sure, we're going to have a right side up kind of a U doing something like that. Question about graph, almost done? Then they also said they wanted us to work only from 0 to 3. When they gave us the problem, they said we're doing this over an interval from 0 to 3. So right here, we're going to cut that graph off. And what we seek is this and that, and then the problem stops to exist. Nothing else matters, just those two zones. Question about the graphing part of that? So part A, it said graph, so mission accomplished. Part B, it says to integrate it. So I'm going to do one integral from 0 to 2 with this formula. Then I'm going to do another integral from 2 to 3 with that same formula. This answer better turn out positive because it's above. The second answer better turn out negative because it's below, and we'll worry about that in a minute. So in terms of formulas, the squared formula is stuff cubed over 3. So that would be an 8 over 3, and I'm not going to do the minus 0 part. I don't think you probably care about that. Minus 6. The x formula was squares over 2, so something like 4 over 2, minus some 0-y stuff. The 8 formula is just going to use like 2 minus 0, so just 2. And that's just using the formulas from yesterday. You okay with that? So this is an add 16. This would be a subtract 12. So that's positive 4. That's another 2 2/3. So this is 6 2/3 on the positive side. Let's go about that. The 2 to 3 is going to be a little bit more of a pain to plug in because the lower number not being 0 is a little bit annoying. So we go 27 thirds minus 8 thirds minus 6. 9 halves minus 4 halves plus 8. 3 minus 2. And that's again just using yesterday's formulas for squareds, for x's, for regulars. You okay with that? Yeah. This part's a positive 8. 5 times 30 halves. This part's a negative 15. This part is 6 1/3. So this is negative 7. Negative 7 outweighs that slightly. This is negative 2/3. And my picture was not necessarily drawn to scale, so I'm not freaked out over the fact that that doesn't look right. But that is way smaller than that. Question about that? Yeah.
How come when we did the integral on that, it got us like the part we wanted, but when we did it on the other one, it didn't?
Because on this, we shaded it ourselves. We shaded between the line and the x-axis. If you're shading between the line and the x-axis, that's what that symbol does for us when we run this formula. This, the book forced upon us something that they had shaded in a space where we didn't like it. If I were the author of a book, I'd have probably shaded like where I wanted it shaded, but that's not what they did. Question there? So now we can answer the questions. One question was to integrate it. The integrated answer, so like A is this graph. B, the integrated answer, we can put these two together as they are. When they use the word integral, this is allowed to be negative. So if we do this, put together with this as they are, the integrated answer would be 6. For C, they asked us to do the area. Area means positive only. So we have to put these together, but positives only, making the negative into a positive, then that would be 7 1/3. Question about that? Here's another way you could approach the one answer, and I leave this up to you how you want to do it, whether you want to do this shortest way or safest way. We could also have done the integral from 0 to 3. If we do the integral from 0 to 3, it'll directly give us this answer. Because that's what this symbol is designed to do, is treat positives as positives, treat negatives as negatives, take them as they come. The integral from 0 to 3 in one big swoop can come up with this 6 answer, if you run the formula, which would have us go 27 over the 3 minus 6, 9 over 2, plus 8 times 3, that's a 24. That's a negative 27, that's a positive 9. Positive 33 subtracts 27, we could get 6 directly. So here's something you can do. If you want to go calculus safe, you do all three things, and you just make sure there was a consistency among them. You know, this just really confirmed that 6, okay? When we did this formula and got the 6, it confirmed for us everything else we had to do probably had to be right, because it also led us to 6. If you want to go calculus quick, you probably like this one the least in terms of running the formulas, because the 2 to 3, it's just harder to plug in number to number than 0 to number. So if you want to go calculus quick, you could go 0 to 3 to get that the total is 6. You could go 0 to 2 to figure out that this was 6 2/3. And then logic would dictate this has to be negative 2/3, because just to have a consistency among those answers, this plus this had to equal that. If you want to go calculus quick, do your 2 favorite formulas and then use logic to figure out the third piece. If you want calculus safe, do all 3 and just make sure there's a consistency among them. 21, you can't do by calculus quick. You have to do by calculus safe, because they were doing the areas, so you have to like get the negative, turn it into a positive, so that the thing calculus quick versus calculus safe, that's applicable to 23 to 26, where you had to figure out everything. If you have to figure out everything anyway, just figure it out whichever way you want to do. On 21, we didn't have to figure out everything. We don't care about the answer from 0 to 4. We need to separately do 0 to 3, keep it positive, separately do 3 to 4, make it negative, add them together. That's just the best way to do 21. Something to 26. 27, they say, graph the function. I'm going to say no thanks. I won't make you do that. Find the average value. Yes, we're going to do the average value. Does anybody remember from a couple days back how we did average values? Division was involved.
You divide by the length.
We had to divide something, yes, by the length of how wide the thing was. What is it you divided by the length? The area is correct. So that was a day where you were like shocked when I did the area of the triangle. You're like, oh yeah, right? There was also like some quarter circles and half circles and weird circles. There were a couple where they just drew a weird graph and you had to do that like cut it up, guessing game thing. Okay. But the day that we did the areas, it was a little bit of guessing game, a little bit of geometry, a little bit of logic. There were a lot of ways that those areas went. We no longer need to do the area with those things. We can now do the area with the integral. The integral will get us the area on these averages. So for number 27, they have the formula x squared minus 1. And they're going from 0 to root 3. So we can just set up that problem to get the area figured out. And I should technically put a dx on there. How's the square thing go again?
Over 3.
Cubes over 3. What's going to happen if we cube this?
3 root 3.
3 root 3 is correct. What's going to happen with the 1? How's that formula go?
Root 3 minus 0.
It goes root 3 minus 0, which would be
Root 3.
root 3. Question about the math of that? What's that going to turn into?
0.
0 is correct, because these 3's cancel. Root 3 minus root 3 is 0. So the top of this formula is going to turn into 0 for this one, which saves you some bother, because if the top is 0, the answer is 0. It doesn't even matter. But for another question, you'd have to figure out the length. So I'll just do that anyway. What's the length of this?
Root 3.
Root 3. We'd subtract these numbers to come up with the length. If you subtract those numbers to get the length, we're good. But we're just after the 0. It asks a follow-up question. I won't make you do that. It asks you, like, at what point or points does it take on that value? What they had in mind is we originally came in with this x squared minus 1 equation. They're thinking we'd like to make that equal the answer we just got and like do some algebra. And I'm just not feeling that. I'm just not. I've never done that. Not planning on ever doing it. But 27 to 30, we will figure out the averages. That's all I'm after. And that's that. 5.4 is where we will, I think, do away with these new formulas like the cubes over 3 and the squares over 2. Those go out the window, and we've got a different way to go about doing this. Those will be called definite integrals. And then the next day, we have a thing that sounds scarier called indefinite integrals. And in fact, indefinite integrals are easier than definite integrals. So tomorrow, formulas go away, new system comes in, and then an easier way to go in 5.5. I think the chapter goes to like 5.7, so we're kind of like on the halfway hump right now. That's a wrap.